Okay, this time in this video we're going to look at probability trees without replacement. Okay, so features the sweets left over from Christmas that are in our house again. We've got 5 strawberry creams, 3 orange creams and 2 coconut ones, which everybody thinks are disgusting. In our house they do anyway. Okay, so there's 10 sweets altogether. So I'm going to draw a probability tree and I'm going to look at the probability of taking 2 sweets the same, assuming I don't replace the first one that I take. Okay, so if you watched the previous video, you'll already know what the first probabilities are, but I'll just go through that briefly. There's 5 red sweets out of 10. So the probability of red is 5 out of 10. Probability is always a fraction, a decimal or a percentage. Okay, so probability of red is 5 out of 10. Probability of orange is 3 out of 10 because there's 3 orange sweets out of 10 altogether. And the probability of blue is 2 out of 10 because there are 2 blue sweets out of 10 altogether. Okay, so I'm going to do the first set of branches, of my probability tree. I'm going to label them red, orange, and blue. Okay, and I'm going to fill in the probabilities. So the probability of red is 5 out of 10. Could write that as 0.5, but I'm going to leave it as 5 out of 10. Orange is 3 out of 10. And blue is 2 out of 10. Okay, so this time we're going to look at the probability of taking 2 sweets the same, assuming we don't replace the first one. Okay, so we know that we can have, on the second set of branches, there are still 3 different possible outcomes, which I'm just going to use initials this time. Red, orange and blue, red, orange and blue, red, orange and blue. So these are all the different possible outcomes. I could take red first, then red second, red first, orange second, red first, blue second, and so on. Okay, so there's 9 different possible ways I could take 2 sweets. Okay, and 9 possible different outcomes. So the difference with this video and the last video, in the last video I looked at what would happen if I took a red sweet out but then put it back again and looked at the probability of taking the second one. This time I'm not going to put it back. So this is probability without replacement. Okay, so if I take a red sweet out now, I've only got 4 red sweets left out of 9 sweets altogether. One of them's gone. So the probability of my second sweet being red is going to be 4 out of 9 because there's only 4 red out of 9 altogether. Okay, if I take a red one first, I'm going to put that back. If I take a red one first, okay, and then I'm looking at the probability that the second one is orange, there are still 3 orange ones, but there's only 9 sweets left. So it'd be 3 out of 9. And to take a blue one the second time, the probability is still 2 blue sweets, but only 9 altogether. So 2 out of 9. Okay. So those are the 3 possibilities that could occur if I took a red one first. Okay, so I'm going to now look, I'm going to put that red one back in and I'm going to look at what would happen if I took an orange one first. So I take out the orange sweet. Okay, that one's gone, I've taken that one out. Second time round, the probability of taking a red, well there's still 5 red sweets, but only 9 left in the bowl, so that's 5 out of 9. Probability of the second one being orange, well there's only 2 oranges left in there now, so that's going to be 2 out of 9, and the probability of blue, there's still 2 blue ones, 9 sweets, 2 out of 9. Okay, and lastly, if I take, I've got to put that orange one back to where I started from. If I take blue first, that's gone, then I've got 5 red ones still in there, out of 9 sweets, 3 orange ones still in there, out of 9 sweets, and only 1 blue one left out of the 9 sweets. Okay, so now I've got my full set of probabilities. Okay, so I wanted the probability of taking two the same. So if we look at the probability of taking two red ones, red, red, probability of red, red is going to be equal to 5/10 multiplied by 4/9. Okay, multiply my numerators together gives me 20, denominators together 90. Okay, probability of orange first and orange second, orange times orange, 3/10 multiplied by 2/9. So the probability of me taking two oranges is going to be 3 times 2, 6 over 90. And lastly, the probability of taking blue and then blue is going to be 2 over 10 times by 1 over 9. 2 times 1 is 2, 10 times 9 is 90. So the probability of red, red, 20 over 90, orange, orange is 6 over 90, and blue, blue is 2 over 90. So these are each of the different ways in which I could get two sweets the same. So to get two the same, I have red, red, or orange, orange, or blue, blue. So when we hear that word or in probability, to work out the probability of two the same, we need to add up the three different ways in which this could occur. So we're going to do 20 over 90 plus 6 over 90 plus 2 over 90. I've already got a common denominator. 20 plus 6 is 26, plus 2 is 28. So the probability of two the same is 28 over 90. If I wanted to know the probability of two different sweets, I know that the probability of two the same and two different are the only possibilities we can have. We can either take two sweets the same or two sweets which are different. There's no other possible ways of that occurring. So 1 take away 28 over 90 would give me the probability of two different sweets, because probability always adds up to 1. Okay, I could think of 1 as being, use this space up here. So 1 take away 28 over 90. This is the probability of two different. Okay, 1 take away 28 over 90. I can think of 1 as being 90 over 90. So that's the same as 1. 90 divided by 90 is 1. Take away 28 over 90 is going to leave me with 62 over 90. So that's the probability of two different sweets. Okay, and the probability of two the same, 28 over 90.